Hi there! This video series is to display my problem-solving and learning abilities. I plan to show that I can solve any programming problem, regardless of whether I already have expertise in a particular language. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. Currently, I am learning Python. I have no professional experience in the language and have only been learning it since mid-January. My only formal training is completing the Python for Programmers course on Execute Program. While I'm picking Python up fairly quickly, I cannot claim any real expertise. Today, I'm vocalizing my thoughts while solving the 41st Project Euler problem. As always, I will link to Project Euler and my repo in the description. Let's dive in. Problem 41 is called Pandigital prime. We shall say that an n-digit number is pandigital if it makes use of all of the digits 1 to n exactly once. For example, 2143 is a 4-digit pandigital and is also prime. What is the largest n-digit pandigital prime that exists? So for this one, I am going to make an assumption, and the assumption that I'm going to make is that this is a 9-digit number. Or at least no more than 9 digits, because when you get to 10, that's not a digit anymore. It's 2 digits. So we're going to start with that assumption. Largest n-digit pandigital prime that exists, and go back to, I think it's this one, yep, problem 38. Here is the last time we dealt with pandigital numbers. I'm going to go ahead and copy all of that code, and in this case, largest equals 0. I'm going to leave that alone. And I'm actually going to start with the largest pandigital number that there is, right? So 987654321, and then we want to go down to 1, and I'm gonna say -1. Obviously there's some stuff we could probably do here to make it more likely to stay pandigital, but I'm just gonna have it be that. So I'm gonna say is pandigital equals true. Then for k in range, length of the string of I. I'm gonna go ahead and change this to an m. And this is going to be I. So, like, in this first case, this is going to be 9. 9 plus 1 is 10, so we're going to go 1 through 9. And actually, we are going to have a string m so that we don't have to concatenate it every single time. I'm going to set largest is equal to m. Okay, so there's a step missing here, obviously. Which is our is prime function. So when would we most recently do is prime? Right here. Okay, so we are going to need to have a different prime function than this one. This one looks right for our use case here. Oh, we obviously will also need as factor. Did not mean to click that button. Go back to this. Okay, just trying to think through this problem, make sure that it works. I think it will be fine. Let's go ahead and run this. Ah, well, of course. It's like, well, this one's Pandigital. This is the largest one that's Pandigital. Sorry, and is prime. M. Now it'll take a little longer. Whether it will complete in under a minute, I'm not sure. I know that Python ends up being pretty fast. But this way of finding primes is going to end up being slower because we're starting at the largest number. And we're gonna go ahead and see how long this takes. Let's see. And there's probably some way to make this a little bit quicker. Yeah, I can think of a couple of ways. For one, if possible prime is less than 4, return true. If possible prime is, or possible prime mod 2 equals 0, return false. That'll just weed out all of the even numbers. Which means that now we can start with 3 and increment by 2, which will reduce a lot of this And obviously we'll get to things where it's like not primes anymore doing it this way, but it's fine. I'm gonna go ahead, it's already been running a couple of minutes, I'm gonna go ahead and stop it. Let's try it again with a little bit of the speeding up. I might have it skip. I think I'm going to have this skip by 2 instead of by 1, and that will also help, because at this size, yeah. Only an odd digit is going to be prime. So let's give that a minute. Let's see. So this probably will not help very much, but it will make it so that if it's like if we get to 2 or 3, it'll return that. It might be faster now that I'm thinking about it to do this a different way. Maybe more like this. I'm just gonna do this rewrite real quick because we're obviously taking longer than our time limit, and that's not going to work for us. Three, 2, a 1 followed by 9 zeros. 1, 2, 3. Stepping by 2. Okay, so this is just going to go through and find all of our primes quick. And I'm going to go ahead and make another method here. Make this is Pandigital. I probably should have split this out to a method a long time ago, since this is at least the third Pandigital problem that we've encountered. But that is okay. So I'm gonna call this is in Pandigital and pass in an n. And say if n is greater than 9, or n is less than 1, return false. Else, we're gonna say for I in range 1 to n plus 1. See. are possible Pandigital, and say if if not string of I in string P and then we just return the is Pandigital. Okay. We don't need that. And we're just going to say if is prime n and is Pandigital n, which I have a feeling this should be the other direction. Because the is Pandigital check is always going to be faster than the is prime check. So and I'm going to change this. The largest Pandigital number it can be is that, so that is the correct, it's the number we're going to go up to. And then we don't actually need this at all. And let's go ahead and let's see. I think that I had this. I want this in here too. And that'll just give us a little bit of an efficiency boost. And let's go ahead and give this a run. And now we just kind of wait. At this point, I think the only problem is efficiency. Oh, right, we have to do the prime check first. This is going to not work. If we don't do the prime check first, then we will not properly get all of our primes. So, let's try this again. Okay. So now, like, the actual this part, all we're really doing is we're going through odd numbers starting with the number 3, checking whether they are prime. If they are prime, checking whether they are pandigital. And just going up to this number, to the 987654321 is going to be the last value we check, because that's the last possible value it could be. But this is like almost 1 billion, so we're checking effectively 500 million numbers, roughly. That order of magnitude. So it is not working very, very quickly. And I'm honestly wondering if there's something else that I should be doing to increase the efficiency here. For instance, do we really need to check whether something is pandigital when we know that, like, the answer is at least a 4-digit number, and most of those primes are going to be earlier? N is greater than 1 million. Actually, I'm gonna make it 1 million first. Say if n is greater than print val, then we're going to be printing n and multiplying print val times 2. Maybe not the bestest way to do this, but basically what I'm saying is kind of give us a print every million numbers, which is going to end up being a lot, but that'll kind of give us an idea of how quickly this is going. Oh, and I actually want to timestamp that. Okay. So I think it might take most of the minute to do the first million. So obviously we're going to need more efficiency here. And let's just kind of see how it goes for these first 60 seconds or so. I could make it skip the number 2, since we're kind of skipping it in this loop. Like, we're skipping all even numbers using this loop, so I could ignore the number 2, but I don't think that would be enough to save us enough efficiency. let's go ahead and remove this check. Okay. Stopping that. I forgot to do equal to. Probably y'all saw it before I did. Okay. Okay, so the first 1,000 numbers I'm not even checking. And I think this is still going to end up taking about a minute. Oh, no, that slowed us down to 4 seconds. Okay. That one took a little longer. And what we're going to end up seeing here is each one of these is taking longer and longer, I think. Because we're having to prime check every single number. Okay. So we're already at the over a minute mark. And we're nowhere near that, like, billion metric. So, obviously, we need some other way of doing this that's more efficient. I think I need to go back to starting at the top. Honestly, because this is just going to take far too long. Go back to my search. Come back to this. Like, obviously it is getting through things, it's just going so slowly that, it's just not going to happen. I'm gonna go ahead and do the thing where I started at 3 and just add by 2 for this. And then we'll be starting with the 9, 8, 7, 6, 5, 4, 3, 2, 1. Going down to 9, 11, 13. Goodness. I'm gonna say, honestly, 2, 1, 4, 2. So we check that 4-digit number that we know is Pandigital and Prime. So right here. That's 100,000. Or wait. That's 100 million. So if n is less than print val, we're going to print n, and then we're going to subtract $100 million. Just to sort of see how this goes. And it went right to 0. Skipped it because we didn't have the -2. Now we should actually see some numbers here. Okay. And obviously this is still taking quite a long time. I'm not completely sure. Okay. Yeah, it took most of a minute to do the first... What is that? About 100 million numbers? Okay. So obviously we're over time here, but I kind of want to see how this plays out. Because it's kind of strange to me. I'm kind of thinking, like, I wonder if there's a way to... Like, is there some mathematical way to know, oh, we hit this Pandigital number, how much do we have to subtract to get to the next Pandigital number? So, like, in this case, there's a, like, if we subtracted 9, it would swap these 2 digits. But that doesn't really work in this case. see. I think I might just let that run a little bit, because if it ends up not finding it in the first... like... if it ends up not being a 9-digit number, then that's kind of surprising to me. I don't actually know if there are 9-digit primes. And obviously there are many other ways we could go about this. And this one is clearly not efficient enough for our algorithm, or for our problem. But I'm guessing it will give us the correct solution here in a couple minutes. Let's see. How do we make this more efficient, though? So, for this... I'm curious how many Pandigitals we are finding, but also, how do we make this a little more efficient? I'm trying to think. Thinking about it, this might or might not help. So I'm thinking, what if we did a PR based on this? Then we did a sort. What is that? PR.sort. And then for I in range. And then if not I equal to PR at index I minus 1, then Pandigital is false. Okay, so we're getting a lot lower than I expected us to get, actually. Let's go ahead and interrupt that. So I don't know if this is actually going to be a little faster. Let's compare it just for the first 100,000. Oops. These need to be angly brackets, not parentheses. Now, at this point, we could start cheating. We could be like, okay, so we got all the way down to this, like, 8-digit number, so it's clearly not a 9-digit number. But I don't know if I want to do that. Okay, so that took 6 seconds, which is significantly less. Like, very significantly a lot less than the last go-round. Wait, no, is that less? It went from 5754. That's a significantly more, isn't it? So 19 plus 60, 79 minus 42 is like 37. This took much, much longer. Okay. It's probably because we're calling a sort. Let's see what other array methods there are. Cancel that because we're taking way too long still. So this is just kind of I'm curious. Right, I undid the -2. Oh goodness. Like, we could start from the other direction, but then it's like... how do we know when we've hit the largest one? And, like, are we going to just keep checking more numbers and more numbers and more numbers until we've done that? So, let's see. Goodness. Okay. So the number of Pandigitals found is ludicrous. And obviously none of those are primes. So I think we should go back to going the other direction. 2143. And again, the problem here is, how do I know when I've gone far enough? Change this to plus equals. That is unclear to me, but... cancel that. going to do. I think it's actually going to be faster coming from one direction or the other, not really. But yeah. Okay, so obviously this is dragging on a bit. And it's going to continue to do so, obviously. So what is a more efficient way of this? Okay. Let's see if converting it to an array is helpful. That should give us a little bit of speed, because it'll say, okay, how many of this value? And let's see if that gives us faster than 40 seconds. At all. Should help us a little bit, because all of the ones where there's, like, say 2 1s will now go faster. But it remains to be seen exactly how much faster. As we observed last time, it was... This is interesting. It didn't print out that first line like it is supposed to. Okay, so no, not faster, and it is not correct. So, double oopsie there. Okay, so why might this not be working? Because this is not converted to a string. Now let's try it. Probably still won't be any faster. Like, honestly, we would probably want to try to get to, like, a few seconds per 100 million instead of almost a minute just for that. But there's almost certainly a better way of doing this than we're getting here. So... yeah, still close to a minute just for the first million. Okay. I've got it. I have an idea of how to make it faster. Having in the sort might slow us down still. But... I'm going to call this simple pan. I'm going to set it equal to that. And then I'm going to say simple pan equals simple pan plus string of I. And then I am going to return simple pan equal to dot join RP. I don't know whether this will actually give us a faster algorithm, but let's give it a shot. No, hold on. Simple pans equals a dictionary. I'm gonna go ahead and start with 4. So that is 1, 2, 3, 4. 5 is 1, 2, 3, 4, 5. 6, 1, 2, 3, 4, 5, 6. I think I need all of these. Well, I don't think I need all of these to be strings, but it might make things a little easier. Okay. I'm gonna go ahead and fill out the rest of this. Just to make this algorithm a little bit more usable. And it occurs to me that I don't even need the keys. Maybe it'd be faster to use the keys anyway. That's fine. Okay, so now can delete this and just do return whether this is in simple pans. So if it is, then it is a Pandigital number, otherwise it is not. This should exit. This should be at least a teensy bit faster. And I think the time to beat is still like 40 seconds per 100 million, so... looks like we might not be beating that. Yeah, still taking 50 seconds. At which point I have to assume that maybe we should be speeding up the is prime somehow. I don't think we can speed this up anymore. And actually, let's go ahead and check. Let's run this experiment. If we're not doing the prime check, how long does this take? Seems like it still takes pretty long without the is prime check, which means there's probably a faster way of doing this. Yeah, it's still taking about 50 seconds without the prime check, so the prime check is definitely not the slowdown here. All of our previous times with the is Pandigital check, we've just kind of done this. If the string is not in here, then it's fine. But now we're at a point where we really need that to be more efficient. And it's not working. So let me go ahead and change this. Nope, I don't want to do those things. That's more or less what I'm doing. Let's see if having it that way makes it faster at all. It might, because we're doing like this part instead. But also with this, like, sorting on array thing, I'm not sure if we can make it the same. I'm gonna do an experiment here. Okay, yeah, we're still taking like 50 seconds. I'm curious whether 1, 2 is equal to 2, 1. No. Thought so. And what I'm trying to see is there a way to maybe be like, oh, this has all the same basically what I'm thinking is strings can be converted into arrays. Is there a way in Python to compare two arrays, and two lists is what they're called? Python lists have same elements. So we could import collections. Okay, so there's a few different ways to do this, I think. Let's try this collections.counter thing. Okay. This might end up being a tiny bit faster, and it makes it into one line. But let's just kind of see how this goes. See whether that also takes like a full minute. Because absolutely wild. Looks like it might even be taking longer, annoyingly. Let's see what else. Okay, so it looks like this is a dictionary. And also, we're at way over a minute. This made it take much, much longer. So... but maybe it doesn't have to. If I did all this up front... I could just do that, and that might be a tad faster. So we're at the, 3-minute mark already. And no end in sight for even the first 100 million, so let's do it this way. I have a feeling that this is not going to work out well for us. I think that I need something better. Okay, so I think this also is going to prove to not work out efficiently enough. So maybe the set equals. I'm gonna try just sets and see how that goes. I don't know for sure that this will work at all. And this one we're going to just have to let run, I think. Because I'm not sure this will do what I want, which is going to be like a set of a string of 1, a string of 1 and 2. Okay, so that's still taking about the same time, but it's getting the correct answer. So, at least we haven't taken a step back. I'm gonna go ahead and remove this check, because that's technically 2 checks, and see if that saves us even a few seconds. And then I'm going to cast both of these to length and compare the length instead of the actual sets. Oh, that won't work, will it? Well, I don't know. We'll see. So that seems to have made it a tiny bit faster. Maybe not as faster as we want it to be, but let's try this. And we're looking for this number of Pandigitals in under 30 seconds, preferably. I do not think that this is under 30 seconds. Okay, that took longer. Somehow. And got the wrong answer. That's why it took longer, is it's kept getting the wrong answers. So this is clearly not enough. Okay. So, string of P is just this. Not I think it was starting to get a little bit faster maybe there, but This does not seem to be working out very well for me either. We're still getting a lot of false positives, so this is not working. Might be helping on time it. I'm hoping that having this narrows it down a little. Okay. Okay, so we're back to like 36 seconds, which isn't super awful. But it's also about 10 times longer than we need it to be. So, what is a better way to check this is in Pandigital, so that it's much, much more efficient. Let's see. So, Python, check whether number is Pandigital. And actually, we're going to go ahead and go to the archives. And we're going to see whether any of the other Pandigital ones have had a little document. So, nope. Nope. Doesn't look like it. Dang it. And, like, at this point, I should throw out there, like, this is gonna give us the correct answer. It just takes so long to run that, like, it does not count. Is it possible that the prime check is actually faster than the Pandigital check? So the Pandigitals found is now only counting prime Pandigitals. So it's going to be a much smaller number, and I'm not going to know whether it's accurate necessarily. But with doing it this way, let's see how long it takes us to get through those first 100 million. Looks like it might be taking a lot longer, actually, to do the prime check first. Which is what I suspected, which is why I was doing the Pandigital check first. But let's see what the data says after we get through the first 100 million. It can't take that much longer, I feel like. Although it's obviously taking more than about 30 seconds. And again, 100 million, there's... let's see... almost $500 million to check. So, the first 100 million, when we get the N up to 100 million, then we still have so many of those left to go. 10, right? Yeah. So, in order for this to work properly, we need to be going through 100 million in about 6 seconds or a little less. And obviously we're taking much longer now than we were. If I remember correctly, there's not a great way for the is prime check to be much more efficient. So this is in Pandigital thing is going to be make it or break it, I think. And yeah, this has been running for like 3 minutes now with no end in sight. So we'll just undo that change. Call it there. Let's reverse the order again. Maybe? Actually... I had a thought. Now, we know from having gone through it before that this is not a 9-digit thing. And we're expecting this to take about 30 seconds. But what we don't know is which 8-digit number it is. And I am willing to bet that this 7-digit number is correct. 1, 2, 3, 4, 5, 6, 7. Yes. Okay, so let's make this... I want to switch this around to be the... other direction, I think. Let's see. 3, so this is like the first 9-digit number. And the largest is... okay. No, that's not what I want to do. I'm trying to think of a way to programmatically be able to be like, okay, well, we didn't find it, in so many numbers, therefore we're just gonna call it. And I think definitely, like, at this point is a good point to do that. I'm just trying to think. Yeah. So first 1,000. And actually I'm gonna say first 10,000. And then I'm gonna multiply by 10. So when n is greater than print val and length of print val, let's do length of the string version of print val, is greater than length of the string version of largest. And instead of having that be an and, we'll just have it be its own separate if, and we'll say break. Now we should actually see this finish. Okay. I'm gonna say +1 here. Let's see how far that gets me. Not far enough. I'm gonna try that and see what that gives me. I have a feeling that it also won't give me the correct answer. It did not. I'm gonna go ahead and do a +2. Okay. So it stays 4, 2, 3, 1 for a while. I'm trying to think of a way that we can do this that isn't just... Well, we know it's not a 9-digit number. Okay, so that'll make it work. But that is being like, well, we know it's not actually a 9-digit number. Let's see what happens when we do that. And there, we've already found the correct answer. So, obviously we met our time limit, but I feel like we did so improperly. So this can just be inside the loop. Not sure why I didn't do that in the first place. Oh, that's why I didn't do it in the first place, because I didn't want it inside the loop. Okay. I'm just gonna... N is greater than print val. This is gonna break too early. Yep. we're gonna have it be in here. Okay. So every time we go up a digit, we check whether we found a new largest. And we actually don't find a new largest for 5 digits. Interesting. Okay. Okay. I am going to cheat here and make this the new goal number. Okay, so now if I just run this, it's going to end up finishing in about 30-ish seconds. I don't like this solution because while we may it technically finish inside of the correct time frame, I don't think we did so in the proper way. But I'm not, at this point, certain how else to do it. Yeah, see, that took 30 seconds. Out of curiosity, I am going to try... Let's see, that's the largest 8-digit. I want to try it the other direction and see if that's any faster. And actually, in order for it to be faster, this has to have a break. Otherwise, it won't get the correct answer anyway. Theoretically, it should be faster to start from the top, but that's only actually true if we know what the true top is, and the true top is closer than the bottom. Or... you know what I mean. Because then you can stop checking digits, or stop checking after a while. Okay, so we got to this correct answer again, and this time in under 30 seconds, so it's slightly faster to start from the top if you start, like, here. If we started from, like... if we, like, come in and we're like, oh, this is definitely a 7-digit number, let's just find it, it finishes in less than a second. Much less than a second. But once you start throwing in the 8, then it takes longer. With the 9, we saw it took several minutes. So yeah. Once again, I'm just going to say Not a huge fan of this solution. I feel like this is sort of cheating. This is sort of being like, well, I know that it's not a 9-digit number. And we don't have a way of knowing that that's like expressed in this code or anything. So, but solved the problem, got the correct answer. Technically, we are able to get the correct answer within the time slot of runtime of 1 minute. So I am going to go ahead and call it there for today, and I'll catch you in the next one.